Hello students, I hope you are doing well. So in the previous video, if you remember, we had derived the general expression for work as Fs cos theta, where theta is the angle between the force and the displacement. Now today, we are going to try and understand three special situations which would occur involving the angle between force and displacement. Now situation number one, the first one is if or when force and displacement are parallel, that is, in the same direction. So now we have a situation where, supposing there is an object lying at rest, a force has been applied to it, and the displacement is in the direction of the force, meaning the angle between force and displacement is zero. Force and displacement are parallel to each other. So the angle between them, theta, in this case is 0 degrees. All this is important. These are all questions ICSE will be asking. So now let's calculate the the work that can be done here. So according to the general expression, work is Fs cos theta. So in this case, it becomes Fs cos of 0 degrees. And cos of 0 degree is nothing but 1. So when I substitute here cos of 0 degree as 1, I get W is equal to F into S. Now, this is that smaller formula that we have been using so far in the previous videos, if you remember. And here we say that maximum work is done. Okay. So now how the questions are asked in ICSE is, when is maximum work done? So when force and displacement are in the same direction, the angle between them is 0 degrees Celsius. Sometimes it's even asked, what is the angle between force and displacement for maximum work to be done? So the angle is 0 degrees Celsius. Okay. So this is one situation. Now the second situation, suppose, situation number 2. When force and displacement are perpendicular, meaning the angle between the two will be 90 degrees. So now we have a situation where, supposing force is being applied on this body and the displacement produces at 90 degrees. This is the displacement. So theta, the angle between the two, is 90 degrees. Now it's a little difficult to imagine examples based on a situation like this, but supposing I am carrying a bucket of water and walking on a horizontal path, okay? Or say somebody has a suitcase on their head. So just let me explain to you. So here's a person with a suitcase on his head. And if this person is moving on a perfectly horizontal path, right? So the displacement, you can see, this is displacement. And here is the force, the weight which is acting downwards. So force and displacement are at 90 degrees to each other. It could be not only on his head, the person could be carrying a suitcase in his hand also. Okay. And moving along. A perfectly horizontal, smooth surface. Then in that case, force and displacement are at 90 degrees to each other. So in this case, let's see how much is the work done. So according to the general expression for work, W is equal to Fs cos theta. So in this case, it becomes Fs cos of 90 degrees. Now again, if you go through your trigonometric ratios in maths, you'll find that cos of 90 degree is 0, right? So when we multiply F into S into 0, this entire thing becomes 0. So here is a situation where we say minimum or no work has been done. So this is the second situation. So maximum work when force and displacement are in the same direction. Minimum work or no work when force and displacement are perpendicular to each other. Now the third situation. Third situation is when force and displacement are in opposite directions. So now we have a situation. Okay. Force and displacement is in the opposite direction. Okay. Again, a little difficult to imagine. Now, but the easiest example of this would be frictional force. When a ball is rolling on the ground, supposing here's the ball, if supposing it's rolling like this, friction opposes this. Okay, so displacement and frictional force. See, they are in opposite direction. Another example is when a body is thrown up against gravity. So gravity is trying to pull it down, the body is still moving upwards. So that is again a situation when force and displacement are in opposite directions. When a body is dropped from a height, then that is the first situation. Force and displacement in the same direction. Now, since force and displacement are in opposite direction, okay, this way, opposite, the angle between them becomes 180 degrees. So in this case, theta is equal to 180 degrees. Okay. Now let's see how much work has been done. So according to the general expression, W is equal to Fs cos theta. So here it becomes Fs cos of 180 degrees. Now cos of 180 is beyond the scope of your math syllabus also, but please keep in mind that cos of 180 degrees is minus 1. So when you multiply F into S into minus 1, we get work as minus F into S, minus Fs. So we say negative work is done. So here, these were the three important situations. First, maximum work when force and displacement are in the same direction. The angle between the two is 0 degrees Celsius. Second situation is zero work being done when force and displacement are perpendicular to each other. The third situation is when force and displacement are in opposite directions, like frictional force acting on a rolling ball. And in such a situation, we say negative work is done. So the simple way to understand this is, supposing with the help of these two pens, force and displacement, say one of the pens is force and another one is displacement. Now, as the angle between them goes on increasing, first, if force and displacement are in the same direction, maximum work. As the angle goes on increasing, less and less work is being done. Less and less work is being done. And finally, zero work. Force and displacement are perpendicular. Then again, more and more work, but negative work. More and more work is being done. Again, maximum work here, but negative work. Please keep that in mind, because force and displacement are in the opposite direction. Now, based on this, one of the most common questions, ICSE's question is, why is the work done by the moon while revolving around the earth zero? You have to give two reasons. Or sometimes they even put just the same question, basically, why is the work done by the earth revolving around the sun is zero? So if you ask for two reasons, right, first thing you have to keep in mind is, whether it's the planet or the moon, while it is revolving around, the net displacement after each revolution is zero. So it has come back to its original place. Then the second reason is, okay, the second reason we have discussed about centripetal force. Now, centripetal force is the force which is directed towards the center and is responsible for changing the direction of the body every instant. And at any instant, this is the direction of the displacement. And here is your force. So force and displacement are perpendicular to each other. So both. So two reasons. Firstly, the net displacement after each rotation is zero, right? And the force and displacement are perpendicular to each other. So of course, cos of 90, you can explain. But again, with that same logic, f is cos of 90 degrees. So this whole thing becomes zero. All right. Thank you. Thank you for watching the video.